Number 1 asks us to solve each of these systems. So you can utilize any method you would like here. There's not one way to do this. So for this first one, I'm going to do elimination, and you can do substitution if you wanted by solving this bottom one for x. I am going to do elimination. So I'm going to rewrite this first equation, and then I am going to multiply this second equation, and I'm going to multiply it by -2. So when I multiply x by -2, I get -2x. Multiply 5y by -2, and I get -10y. And then multiply 40 by -2, and I get -80. This gives me opposite numbers in front of the x's. So I am going to add these two equations together. So now when I add, 2x plus -2x is 0. And then -4y plus -10y is -14y. 10 plus -80 is -70. Then we'll be able to divide by -14. And we end up with y equals 5. Okay, so y equals +5. Then I'm just going to start my ordered pair solution over here. So we just figured out the y value as 5. Now, once you've gotten one of your values, so once you've gotten one of your variables, then you can just plug it into either equation. So I'm going to take this original equation here of x plus 5y equals 40, and I'm going to plug in the y value there of 5 in for y. So then we get x plus 25 equals 40. Then we can subtract 25 from both sides, and we would get x equals 15. So then our solution would be that x equals 15 and y equals 5. Then for part B, again, you can do whatever you want here if you want to try and do substitution or elimination. So I'm going to do elimination again, but I see that I can't just multiply one equation by a number easily to get an opposite. So I am going to make the x's opposites. So I'm going to make them 6's, okay, 6 and -6. So I'm going to take this top equation and multiply it by 2. So 2 times 3x gives me 6x, 2 times -5 gives me -10y, and then 2 times 4 gives me 8. Then for the bottom equation, I'm going to multiply this by 3. So 3 times -2x is -6x, which got me opposites, which was my goal. And then 3 times 6y is 18y. And then 3 times 18 is 54. So then we can go ahead and add these together since we have opposites, and opposites add to 0. So 6x plus -6x is 0. -10 plus 18y is 8y. And then 8 plus 54 is 62. Then we'll be able to do 62 divided by 8 because we'll divide both sides by 8. And we end up with y equals 7.75. So if I start my solution ordered pair over here, my y value that I just got was 7.75. So now we'll go ahead and plug that into one of our other equations. So I'm just going to take this bottom one. Doesn't matter which one you choose. So it's going to be -2x plus 6 times our y value, which is 7.75, equals 18. So we'll get -2x, and then 6 times 7.75 gives you 46.5. So then we'll be able to subtract 46.5 from both sides of the equation. So then we get negative 2x equals negative 28.5. So then we'll divide both sides by negative 2. And we end up with x equals positive 14.25. So then our solution here is this ordered pair of 14.25 comma 7.75. Number 2, Tyler is solving this system of equation. He can think of 2 ways to eliminate a variable and solve the system. So the first way that he thinks about it is that he can take the first equation and multiply by 2. Then he could subtract the bottom equation. So his first thing is he's going to multiply this top one by 2. Then his other strategy would be that he can take the bottom equation and multiply it by 2. Then add the result to the first equation. Okay, so multiply the top one by 2 and subtract, or multiply the bottom one by 2 and add. So do both strategies work? Explain or show your reasoning. So let's just write out the first one. So if we take this top equation and we multiply it by 2, so 4p times 2 would be 8p. 2q times 2 would be 4q. And then 62 times 2 would be 124. And then he would have kept the original second equation the same. So he would have this. So is he able to subtract these now to eliminate one of the variables? And the answer to that is yes, because 8p minus 8p would be 0. So he would have worked to eliminate the p. So this one is good. So then let's take a look at the second option he said. So he was going to leave the first equation the same in his second idea. So he would have left that top equation the same, and then he wanted to multiply the bottom equation by 2. So 8p times 2 is 16p. Negative 1q times 2 is negative 2q. And then 59 times 2 is 118. And then what he wanted to do here was subtract these. So subtract these equations. And we know with this one, he wanted to add the results here, not subtract. So subtracted in this first one. He wants to add here. And we know that when we have opposite numbers that we add together, they'll equal 0. So in this second one, he would have eliminated the q variable. So both strategies work because they both eliminate a variable in either one, and then you can solve for the remaining variable and use it to solve for the other. Number 3, Andre and Elena are solving this system. Andre's first step is to rewrite this second equation here. Not to rewrite the second equation, just to write it as 3x equals 9x minus 30. So replace the y with 3x. So substitute in. Okay, so Andre's first step was to do substitution. Elena's first step was to create a new system. So Elena took the first equation and multiplied by 3, right? So she went from y to 3y, 3x to 9x. So she multiplied this top equation by 3. Do you agree with either of these first steps, and explain your solution? So I kind of explained that, yes, I agree with both of them because we said that we did substitution. So for this first one for Andre, so yes, I agree with Andre's first step because he substituted. 3x in for y, and we know that y equals 3x, so this is a valid move, right? So we're totally allowed to do that since we know that y and 3x are equal to each other. So this is an acceptable first move. And then he could solve for x, right? So now he only has one x variable or one variable, so he'd be able to solve for x and use it to solve for y next. So then for Elena, yes, I agree with Elena as well. And then let me make this a little bit smaller so it'll fit. So yes, I agree with Elena because she just took the first equation and multiplied both sides by 3. So both sides will remain equal when you multiply by the same number. And so now she has her x's are the same, right? So she got her x's to be the same. So she'll be able to subtract her equation. So once you get the coefficients to be the same, then you can use elimination by subtracting. So she'd be able to subtract here. So 3y minus y would be 2y. 9x minus 9x would be 0. And then 0 minus negative 30 would be positive 30. And she'd be able to have eliminated the x and solve for y. So either way is good. Both first steps are good. Number 4, select all systems that are equivalent to the given one. So if we take a look at each one, try and see what's different and see if you can come up with a valid move that they made to get there. So when we look in this first one, we see that this top equation is exactly the same. Then we see that we've changed the bottom equation except for the 4. They changed the D and E terms, but they left the 4 the same, and that's not allowed. You can't just change parts and not the rest. So that's not going to be equivalent. Equation B, we see they changed all these top numbers. And so we got to try and figure out how. So they went from 6 to 30. So that looks like they multiplied by 5. So then try 4.5, multiply it by 5, and they get 22.5. 16.5 times 5 is 82.5. So here they just multiplied the top equation by 5, which is acceptable. So then let's look at the bottom equation, and they just ended up leaving it the same. So that's okay. So this one is equivalent. Part C, they again multiplied the top equation by 5, so we can see that from part B. Then down here, they changed every term. So they went from 5D to 30D. That looks like a multiplication by 6. So let's check. 0.5 times 6 is 3. 4 times 6 is 24. So they multiplied every term by 6. So that's good. So those would be equivalent. D, they left everything in the first equation the same. Then for the next one, they went from 5D to 6, 0.5e to 0.6e, and 4 to 4.8. So let's see if they multiplied everything by something. This one's a little bit more challenging, but we got to 6 and we started at 5. So let's look at 6 divided by 5 to see what they multiplied by. So 6 divided by 5 gives me 1.2. So now we want to see if they multiplied all of these by 1.2. So if we take 0.5 times 1.2, we get 0.6, which would be this. And if we take 4 times 1.2, we get 4.8, which is here. So they just multiplied everything by 1.2 for this one. So this one is equivalent as well. And then let me move this equation down here so that we can see it as we finish for parts E and F. All right, so then E, they changed this first number to a 12 from a 6, so that appears to multiply by 2. And 4.5 times 2 is 9. 16.5 times 2 is 33. So they multiplied everything by 2 there. Then this bottom equation, they went from 5 to 10, and then they stayed at 0.5. So this one is bad because they didn't change this one. So they changed the first and last, but not the middle. And then F, they have the same equation for the top one. And then if we take a look at the bottom, they changed everything, but by how much? So for this first one, really the middle one's the easiest one for me to see. So they took 0.5 and they multiplied by 10 to get to 5e. But 5 times 10 would have been 50. So then this one would have needed to change to 50, and it changed to 11. So this one is not equivalent. All right, number 5, here's a system of equations. Write a system of equations that's equivalent and describe what you did. So this has a bunch of different things you can do. So the answer that I write down is not the only answer. So this depends on what you like to do. So for me, what stuck out to me first is this first equation has just a p variable, okay, like 1p. So what I'm going to do is subtract 8q from both sides for that one to solve it for p. So I'm going to go minus 8q minus 8q so that I get p equals negative 8 minus 8q. That's going to allow me to set up substitution. So here's my new system. So there's my new system. I just solved the top equation for P. And again, you can do a lot of other things. That's just one option. And so how do I know that my new system is the same? Because I subtracted 8q from both sides of the first equation. And when you subtract the same value from both sides, you the two sides stay the same, stay equal. Okay, because we subtracted the same thing from both sides. So if they started equal, they're going to remain equal because we subtracted the same thing. Okay, therefore the solution won't change. So again, what you do in part A is totally up to you. And then you would just explain in part B why what you did in part A works. Number 6, the cost to mail a package is $5. Noah has postcard stamps worth 34 cents, and he has first class stamps worth 49 cents. Write an equation that relates the number of postcard stamps, P, and the number of first class stamps, F, to the cost. So each postcard stamp is 34 cents. So we do 34 cents times the number of postcard stamps. And then we would add 49 cents times the number of first class stamps. And that should total really at least $5, right? So we have to put at least $5. So really we could say this is greater than or equal to $5, but it has to be at least equal to $5. So then this one wants us to solve the equation for F. So we would first subtract 0.34p from both sides. So we would be at 0.49f is equal to $5 minus 0.34p. Then we would divide both sides by the 49 cents. and we would get F equals 5 minus 0.34p divided by 0.49. So there would be our equation solved for F. Then the next one wants us to solve the equation for P. So I'm just going to erase this first step here, because now our first step is going to be to get P by itself. So we're going to subtract 0.49 F from both sides. So then we're going to be at 0.34p is equal to our $5 cost minus our first class stamps. Then we'll divide by the 34 cents. And that will get us our number of postcard stamps. So 5 minus our first class stamp cost divided by the cost per postcard stamp. So now part D says that we've bought 7 first class stamps. So if we buy 7 first class stamps on the package, how many postcard stamps do we need? So we want to know how many postcard stamps we need. So we'll work with the P equation. So we'll do 5 minus 49 cents times the 7 stamps that we know we have, and then divide it by 34, the cost per postcard stamp. So when we do this, 49 cents times 7 gives us $3.43. So then we'll subtract that from our original 5. So 5 minus our 343 gives us $1.57 that's left. And then we'll divide that by 0.34, which is the cost per postcard stamp. And that tells us we need 4.617 postcard stamps, which isn't possible. You can't buy a partial stamp. So we're going to need to put on 5 postcard stamps in order to get to our at least $5. Number 7, here's another system. Find at least one way to solve this system by substitution. Show your reasoning. Then how many ways can you find? Regardless of substitution you do, you should get the same solution. So this one wants substitution. So we're going to solve for a variable. So first time, I'm just going to subtract this 2x from both sides here and get to y equals 14 minus 2x. Then I'm going to plug this back in for y. So we would do 2x plus 7 times our y, which is 14 minus 2x, is equal to 8. So I just plugged it into that first equation. So then we'll multiply the 7 times the 14, which gives us 98. And then 7 times negative 2x gives us negative 14x. Combine my like terms here, I get negative 12x plus 98 equals 8. So then we'll get the 98 and the 8 together by subtracting 98 from both sides. So I get negative 12x equals negative 90. And then when you divide by negative 12 here, we'll get that x equals 7.5. Then we're going to be able to plug that back in, right, to this equation and get y. Okay, so y equals, we know that y equals 14 minus 2x. So this is going to be 14 minus 15, which is negative 1. So our solution here was 7.5 negative 1 if we did the substitution that way. So this was solving it for y and plugging it in. Then it asks you to see how many other ways you can do it. I don't think you need to, sit and do a bunch of them, but I'm going to show you one other way that I see to do this. So we could take this equation and solve it for 2x instead. So we could get 2x equals 14 minus y. And the reason we could do that is we see a 2x in this equation. So we could plug this whole thing in for the 2x. So where we see 2x, we would put 14 minus y. Then we see the plus 7y equals 8. So I just replaced it into this part. So let me get rid of the rest of this so it's easier for us to look at. But where I saw 2x, I just replaced it with the 14 minus y. So then we have 14, negative y plus 7y is 6y equals 8. Then you could subtract 14 and you get 6y equals negative 6. Divide by 6 and you get y equals negative 1. And then you could plug it back in to solve for x and you'd end up with this same solution. So that's another one that I see. There's a lot of them that you could do, but those are kind of the two easier ones. Number 8, here's a system of equations. Write an equation that results from subtracting the two equations. Okay, so we're going to subtract these two equations. So negative 7x minus negative 7x, which really turns into a plus, is going to be 0. Okay, so this x part is 0. Then we're going to have 3y minus 10y. And 3y minus 10y is negative 7y. And then we'll have negative 65 minus negative 135. And negative 65 minus 135 really is a plus, right? So this turns to plus, and you end up with 70. So when you add these two equations together, when you subtract these two equations, you get negative 7y equals 70. Number 9, a grocery store sells bananas and grapes by the pound. Priya buys 2.2 pounds of bananas, 3.6 pounds of grapes, and it totals $9.35. Andre gets 1.6 pounds of bananas and 1.2 pounds of grapes for $3.68. Here's the system that represents that equation. Explain why it makes sense in the solution. In this situation, that the solution of this system is also the same as the solution to this equation. And so what we can see that they did here, and let me clear out all of this ink here. So what we can see here is that they actually took and added these two equations together, right? So they did 2.2 and 1.6 gave them 3.8. 3.6G and 1.2G gave 4.8 pounds of grapes. And then the total cost. They added these together. So basically, what they did is added, so it is the same because we added 1.6B and 1.2G to the left side of the first equation. And we added 3.68 to the right side of the equation. And we know that 1.6b plus 1.2g equals 3.68. So we added the same value to each side of the equation, which means the equations are equivalent, so the solutions will be the same, or the solution will be the same. So when you add the same thing to both sides, the same value, it doesn't change the equality, so you'll still get the same solution.